Angles and their measures. Angles and their measures. All right. Here's the objective. I will be able to convert between degrees and radians. Also find the circular arc length. Degrees to radians and find the circular arc length. All right. Help me out with one word from the chat. Hello there, Satar. In the live stream comment or in the public chat or your whiteboard, all these are great things to share your thoughts. All right, let's keep going. I see length, I see convert. I'm going to start with a very simple a concept here, develop that purposefully so I can get you on the correct page. So anytime you see rectangular coordinates like this one, you could use it to describe circular angles or rotations. So usually we start with this here, and then from here to here is a 90-degree angle. We all know this by now. So this is 90 degrees. And then 180 would be here, 180 degrees. And then down here is 270. And then back to here, you start at 0, and then you're going to end up with 360. Okay. That's one side. This is one measure of the angles. There's at least there's 3 of them that we use. There's only 2 at this math level, but the 2 are, for example, let's just start with a simple one, like if I want to measure temperature, well, you could use Fahrenheit or you could use Celsius, right, for temperature. If you want to measure distance, for example, you could use inches, right, or you could use centimeters, standard and metric. If you have done some chemistry, you know that there's different measurements, obviously, and physics as well. So in measuring angles, there's also 2 types, at least the one that we're talking about here. There's one more, but that's not what I talk about today. There's 2 types. One of them is called degrees, just like little circle here. And then there is also a radian. And the radian is referred to by pi radian. Okay, pi radian. We usually like shortcuts in math, so we just use pi. So what is this pi and how is it related to the degrees? That's what we're going to talk about today. So first thing first, if I want to know how many angles in a full rotation, I want to go counterclockwise like this, counterclockwise, then I'm going to land over here, starting with my initial side, and then terminal side would be the last one that I land on. The other item also I want to mention is you're able to break this 90 here into 2 equal parts. So it's be 45 here. And from here to here is going to be another 45, right? So this is 45, the first 45, and then second 45, and this will be the third 45, which means 90 plus 45. How much is 90 plus 45? How much is 90 plus 45? $135 degrees. And then 180, you're going to find yourself landing at 225. And then here you're going to find yourself landing at 3. How much is 360 minus 45? 360 minus 45. 315. Okay. So you know you're going to land here somewhere, 315. Obviously, you could also break this, or you could just do increments of 30, for example. So the first 30 is going to be here. Add to that another 30, it will give you 60. Add to that another 30, it's going to give you 90, etc., etc., etc. You get the drift here. So in measuring angles, you have to have something called the initial side. That's where you start. And then there's a terminal side. The terminal side would be the one that you terminate your angle at. Terminal side. Remember that default rotation is counterclockwise, against the clock. Counterclockwise. So what is a radian? Well, let's take a look here. We looked at degrees just a few seconds ago. What is radian then? So a radian would be something like what you're looking at in this case here. You have a circle of a radius of 1. Okay, so I'm going to actually put a circle here, radius of 1. Pretend this is a circle here, a perfect circle with a radius of 1. My R is going to be 1 unit, whatever you want to call it. Which we actually going to spend a lot of time on this circle in this chapter, and the next one. It's called unit circle, 1 unit circle. So the radius is 1, and then you want to find out what is this radian thing is. So follow along with me here. I will travel a distance of 1 on this curve. So I have 1 here as radius, and I traveled on this curve a distance of 1 unit also. And I obviously will land on the same, I'm going to land on the same radius lengths, because radius doesn't change. Radius is always 1, right? In this case here, it's always 1. So this is what they're talking about here. A radian would be the measure of 1 unit as an arc length around the circle with a radius of 1. So basically you have 1 here, you have 1 here, you also have 1 here, but remember this one is curved. It's not a straight line. And there is an equation for that. There's an equation how to find this curve here, the length of this curve. You can't just measure as like, because it's a curve. It's not a straight line. You can't just use a distance formula for this one. You have to use another formula. So anyway, so this is the first radian here. So I traveled as much as the radius, and this is 1 radian. Well, what happens if you traveled again another radian? Look at this one. That's going to be 2 radians. Okay, what if I want to do it again? 3 radians. Okay, now can somebody punch in the number calculator and find me what is pi? What's pi equal to? Exactly, it's 3.14. Hold on a second. 3.14 of what? Well, this is exactly what they're talking about here. A radian measurement. It is pi radians. 3.14 of what? Of the radians. So you have 1 radian. You have another radian, that's 2. You have third, that's a third radian, and a little bit more, 1/4. And that's why the pi here is 3.14 radian. Okay, 3.14 radians. A little bit over 3, 1/4 radians. Just a quick check here. Did you guys have you guys seen this before in math? Explained this way? Have anybody seen it explained in the terms of radian? What's the term of radian? Awesome, great. So this is the way. Actually, first time I'm teaching it this way. I found it to be helpful just to give a pictogram of what is a radian, not just do problems with that. Again, what if I want to continue with this thought? Oh, sure, keep going. So I'm going to add another one. I'm going to add another one. I'm going to add another one, another one, another one. And you're going to find yourself actually down here exactly at that 0 point or a 360. 0 or a 360. You'll find that you're actually exactly on 2 pi's. Will land exactly here. So a 2 pi radians. Because pi is 3.14 of the radians. and 2 pi would give you, how much is like 3.14? You just have to multiply this by 2. 3.14 by 2. Land exactly on top of the 360 degrees. Okay? So that's the concept of the radians, of the radian measurement. So now let's talk a bit about the 360. I have a triangle here with theta, and it's a hypotenuse. There's a side here facing me, and there's obviously it's a right triangle. And this one here is also same triangle, but I want to measure this length here. I want to measure this arc. Not S. I want to measure the arc. This side here. So again, you can't just use a straight line or a distance formula between 2 points because that's a curve. It's not a 2-point. Unless you're able to curve it, to have the curvature also measured. So in math, we use Greek letters to indicate angles. One of which is kind of a famous. It's actually a celebrity in math, which is a theta. Looks like a 0, but it's not a 0. It's like a 0 with a good-looking scarf or something at the top or belt. This theta is also one of the other family members. They have beta. And if you're in software, for example, you've heard of the beta version. Like they tried this thing before they released it to people. They tried this program or software. There's also alpha. There's gamma. There's some other. There's alpha. There's gamma. There's some other Greek letters. But a really famous one is among them is theta. So we're gonna use theta a lot to indicate angles. We're gonna avoid using x's and y's as much as possible, obviously. But the focus is going to be using this dude here as the angle. We're trying to reference an angle. Theta is a central angle intercepting a circular arc of length A, which is this dude here. That's A. The measure can be in degrees, measured in 360 degrees, once round, or also radians, which means it's an arc length of what we just talked about previous slide. You just could keep going with this arc length and add it up to get you there. What is a radian? A radian is a central angle of a circle that has a measure of 1 radian, and it is if it intercepts an arc with the same length as the radius. So again, this is an A as my radius. And I also have another A here, and I travel the same amount here. We call this as 1 radian. 1 radian. Okay, here comes the fun part. I want us to convert from one system to the other. How can we convert from one system to the other? So, for example, this one I'm going to convert from degrees. I'm going to convert from degrees, which is this little thing here, circle, to pi radians. Remember, how do I convert from degrees to pi radians? So if I have degrees, I want to get rid of degrees, obviously, to end up with pi. So I have to multiply what I've got here by pi over 180 degrees. Why? Because you're going to cancel the degrees. If you have degrees at the top, you're going to cancel with the bottom. So let's take a very simple example here. I'm going to do 180. 180 degrees. I want to convert that to radians or pi radians. Or if you guys remember, we said we're not going to use like radians. We just say it's pi. Okay. So I'm going to multiply 180 times this conversion formula here, which is going to be times pi over 180 degrees. Don't forget that. And now if you look closely here, you actually could make this guy also a fraction, right? You could make this dude a fraction, just divided by 1. So basically I have a top and bottom fraction, which you could simplify. So I'll take care of the degree, right? That's going to go bye-bye. And 180 divided by 180, how much is that? How much is 180 divided by 180? That's just a 1. And I have 1 times pi. So that's just a pi. That's why, if you guys remember from my last slide when I did the Cartesian coordinates, we said this is pi. That's also the reason. This is 180 and it's pi. Because of that conversion factor. So once again, to get rid of degrees, make sure that you use the formula which has the degrees at the bottom, because you have degrees at the top, you need to cancel that out by that. So let's practice this a little bit more of this. I got 180. What if I wanted to do? So I'm gonna go wild now. I'm gonna do 270 degrees. How much is that in pi radians? I don't know, but I could find out. I want to multiply this by what? Can somebody help me? Multiply this by what? Pi, just pi? Can't just do it by pi. Here we go. Pi divided by 180 degrees. The degrees are going, and that's also another safety check for you, just in case if you flip these. If you flip the 180 in pi, this is another check, safety check for you. You need to get rid of the degrees. If it has to be at the top and has to be at the bottom. And now I also could get rid of the last zero, like this, right? And 27 divided by 18, how much is that? How much can you simplify that? 27 and 18. Somebody's asking, will it always be? Yes, it's always 180. Yes, Gavin. Very true. Pi over 180. Yep, that's very true. No decimal. Give me, yeah, exactly. I need it in a fraction. So somebody's saying this is a 3 over 2 pi's, because 27 goes into the 9 3 times, goes into the 18 goes into the 9 twice. So now in this, when you write 3 over 2 pi, you also, I mean, I'm going to write it in different ways here, but it means the same thing. 3 halves of the pi, or also you could say this is 3 pi over 2. Both are fine, both are acceptable. So 3 halves of the pi, or pi over 2, which is interesting. 3 halves of the pi. That's very interesting. Can you tell me why it's interesting, Armani? Well, let's take a look. Why is it 3 halves of the pi? What does it end up like that? Well, let's take a look. If you guys remember, we said this is a pi, right? This is a pi, or 180. Or 180. This is not divided by the way. This is just or 80. So it's the 270 is down here. So you basically have half of the pi and another half of the pi, right? That's half of the pi. This is another half of the pi. And this is a third half of the pi. Half plus another half. Well, that's why it's 3 halves of the pi. Half plus half is 1, plus another half, that's 3 halves of the pi. Okay, more on this to come, by the way, for the unit circle. You'll love it. You're going to enjoy that unit circle. Okay, anyways. What if I want to go and ask you to do something weird? For example, what if I want to go to 135 degrees and I want this in pi radians? How do I get 135 degrees in pi radians? Multiply it again. Just chugging along, following the same rule. There's no magic here. I gotta multiply it. Thank you, Coomer. I'm gonna multiply it by pi over 180. Chugging along here. And what do you think I'm gonna get on this side of the pi radians? How much would this be in pi radians? Come on, you guys. Don't be afraid of fractions. Three pi over 4. I wonder. 3 pi over 4. Interesting. I'm waiting for more responses, by the way. I'm waiting for more feedback from you guys. Share your thoughts. We need more people. George is doing an awesome job here. We want more. We want more. We want more. So my question to you, what did you divide it by? I mean, I got rid of this degree, right? And I'm going to get rid of this degree and this degree. And then did you divide by 5? Did you divide by a number? Jordan, not sure if you're writing. Okay, yep, I see that. Looks good. I see that, Jordan. Good job. Somebody said they divided by... no, don't just use a calculator, you guys. Don't kill me. 15. Somebody said 15. So they divide this by 15 and this by 15. Could we also divide by a bigger number than 15? And then by 3. Got you. I like that. So she said 15 first, and then and then further divided by 3. So what is 3 times 15? Here we go. Try to divide by 45. Try to divide by 45. Okay? So if you divide by 45, you're going to get yourself 3 over 4 of the pi. So 135 degrees is 3/4 of the pi. Well, again, let me give you the shortcut here, or a different way to think of it. In here, I'm going to start with 0, as we said. This is 90. 135 happens to be here, by the way. 135. Exactly in the middle. So I'm expecting to see 45 here, if you guys remember, right? It's 45 degree here. 45. And there's also another 45 here. So in this case, I'm going to actually count by 45s. I'm going to count by 45s. So if this was the first 45 and then the second... So this is a quarter, right, of the pi. It's a quarter of the pi. Another quarter of the pi. And another quarter of the pi, that's 3/4 of the pi. See what's going on here? 1/4 of the pi. 2/4 of the pi. 3/4 of the pi. I'm counting by 4th. And that's why it's actually 3/4. So you're actually able to mentally look at that by having it chopped into 4th pieces. That's another way to look at things. All right, champions. Based on what I just said, can you find me 225 in pi radians? And I bet you Kumar is going to tell me to use a formula. I know he's all about that. What do I need to use? Hello? Anybody home? That's a lot of you writing, but I can't see anything yet. This might be a delay in the chat or something. Okay, George is saying it is 5, 4. How did you get that? How did you get that, George? Come on, you guys. Somebody has to compete with George. We can't just leave things the way it is here. Come on. Healthy competition. Well, if I kept on this thought here, this is a 4th, this is a 4th, another 4th, another 4th, another 4th will get me down to 225 here. Another 4th. So I got 3/4, 4/4, 5/4. So that's if that's without actually looking, without doing any conversion here with this formula here, you are able to predict correctly that you're going to land at that location, which is 5/4 of the pi. 5/4 of the pi. And by the way, this also makes perfect sense. 5/4, that means you have you're over the pi, right? A pi is 180 down here. If a pi is here, you're more than 1 pi. Well, that's obvious. 225 is more than 180, right? So you already passed the 4/4 of the pi. 4/4 is 1 pi. You pass that by 1/4. So you have another fourth, which is the 5/4 of the pi. All right, champions. How are we doing here? Are we doing good? Give me a thumbs up. We're doing good. So we can move on. I know I kind of spent too much time here, but it's worth it. Give me a thumbs up if we're doing good here. And by thumbs up, I mean, obviously, if you need more practice, you tell me, obviously. Otherwise, we're going to move on. So now, what do you think is going to happen if I wanted to convert in the other direction? What if I want to convert from radians back to degrees? Well, all what you have to do in this case is to flip that conversion factor. So, for example, if I have, I'm going to start with the easy one first. I'm going to start with pi. To go to pi radians, you actually multiply by 180 divided by pi, 180 degrees divided by pi, because you want to get rid of the pi. Okay, so I'm going to start with the simple one, which is pi. I want to go from pi all the way to degrees. Well, again, Armani, what you have to do is multiply this dude here by 180 degrees divided by the pi. And remember, this guy, you could divide this by 1, right? So basically, you have 1 pi at the top, bleep, bleep, with 1 pi at the bottom. That's gone. Leaving it with 1 times 180, which is 180. Well, that's not surprising because we just looked at that and we saw that pi is 180. Yeah? Remember that? Pi was 180. Pi was 180 and it was here. It was on this side, 180. Or the pi. It was here. I remember that. All right, now let's play with something else. What if I wanted to do pi over 4? Okay. I want to go from pi to degrees. What I should multiply by? Somebody talk to me here. Abby. Abby, what do you think? What do I need to multiply by to get from radians to degrees? Abby, do you copy? Alan and Alexa. Houston, do you copy? Houston, do you copy? Houston, do you copy? Here we go. Alexa. Okay. What did I multiply by, Alexa? Well, either over pi. Simple as that. I'm not going to ask Coomer again. Because this boy just knows that you just have to follow the formula. Anyways, so the pi's are going to go bye-bye, which is what I desire. 180 divided by 4 is how much? Can somebody tell me what's 180 divided by 4? 45 degrees. 45 degrees. Is that true? Well, let's take a look. If this whole thing is a pi, which means this is half of the pi. That's the pi over 2, by the way, or 90. Well, what is 45? Well, 45 is half as much as that, which means pi over 4. If this is a fourth, if this is a half, you slice that half in 2, you'll get a quarter. And that's why 45 degrees is pi over 4. All right, one more and then we're going to let go. Let's do an awkward one. 7 pi over 6. How do you convert 7 pi over 6 to degrees? Any thoughts, Ali? Any thoughts, Satar? Thank you, Ali. Yes, that's the first thing you do. You just follow this formula. 180 divided by pi. All right, good. And then I will see my eyes looking at what? The pies are going to go. Bye-bye. No pie. Does anybody here like pies? I'm not really a big fan of pies. Does anybody like apple pie? Pumpkin? Yeah, I don't know why I don't like pies. Especially apple pies. Pecan? I might look into that. Okay, Comer. Let's focus. So now I've got, how about the 180 and 6? I think I could see something here. I mean, simplify. The 6 divided by itself once goes into itself one time. 180, which is 18, by the way. 18 over 6 is 3. That's going to be 30. So 30 times 7. How much is 30 times 7? Let's go back here. 30 times 7 is how much? 30 times 7. 110. 110. Now also this one has its own little tricky shortcut as well. You could think of it as, and I'm trying to plant some seeds here for this chapter. Hopefully you're gonna get my drift here. So anyways, this is 90. This is 180. 270. And what I was giving you is 7 pi over 6. So basically I'm going to start counting by sixths. 1/6, 2/6, 3/6, 4/6. So this is my, what's pi over 6? What is pi over 6, by the way? Just pi over 6. Like what is 180 divided by 6 in 6 pieces? Come on here, champions. Come on here. Work with me here. Come on. 180 divided by 6, it's 30. So this is 30, which is 1/6 of the pi. I'm going to put that in a different color. Pi over 6, or a sixth of the pi. And then you're going to land on 60. That's 2 of them. 2 pi over 6. Right? And then 90, which is 3 pi over 6. And then you're going to get here to, what's this one here? Does anybody know? 120, 150, right? And then 800. And then all of a sudden you see yourself looking at this dude here, which is 210. So you have 1 6, 2 6, 3 6, all the way to here, 6 6s, and then another 6, that's 7 6s. So that's why you got 210 on exactly on 7 6s here. All right, champions. So once again, to convert from degrees to radians, you multiply by pi radians divided by 180. To convert from radians to degrees, you multiply by 180 divided by pi radians. Here's a list of a table of angles that is in degrees, and then the same angle is in pi radians. Okay, pi radians here, the second column here. So you might want to just try these on your own. I would start with 0. I'll start with 0, and well, that's 0 times anything is going to be 0, right? And then you're going to do the 30 from degrees to radians, and I would just alternate. For example, one time you do like this, and then the next one you go backwards like that, from degree to radians, from radians to degree, etc., until you hit all of them here, which I have alluded to in the previous slides. All right, champions. This one is a little bit interesting. So as you zoom in, our cell phone was really, a family member's cell phone was nearly not working, and the pictures are very important to us, since just like your parents, you want to take pictures of your kids and stuff. So we had to buy a phone, and one of the phone specifications that we were looking at is actually when you're able to zoom in, you see things better. Like you take a picture, but you zoom in. So, if, like for example, if you want to enlarge the picture or print or do something. So, anyways, what I'm trying to say here, if you zoomed in the degree itself, for example, if I zoomed in at the degree. For example, let's say I want to this one here. If you looked closely at the degree 150, can you break the 152 further degrees into further components? The answer is yes. You could actually zoom in to a into the angle to get you a better kind of more pixels, if you want to say that, like in cell phones, more pixel. So the better the pixels, the more that you could zoom in, and does not distort the image. So I want to zoom in. So if you zoom in the degree, you'll find out that you're looking at something called the minute. Minute is part of the degree. And then the second is another part of the minute. Just almost like a clock, right? So the clock, you have the hour, and then you have a minute, and then you have a second. It's almost the same thing. You could break this down, right? Like every hour has 60 minutes, every minute has 60 seconds, etc. With a little bit sliced different measurement though. So the angles have also their kind of further components that have more detailed components. And the components of the angles are the degrees. That's the first one, the big one, just like the hour. And then you have a minute with this apostrophe here. And then you have something called a second, which is 2 apostrophes here. So the question, how do you convert this here to the actual measurement? Like I want to say it's 152 points, whatever the number is. So what you do here is you multiply the angle. You just leave it the way it is. The degrees, you can't divide that and further. 152 is just the whole number. You can't divide that. But you're going to take the 50 minute and divide it by 60 and add it to what you have. You're also going to have the seconds, which is the 29 seconds here. Divide that by 3600, and add that to the number that you've got. And obviously you're going to look at a very, very tiny, very small number, like 152.25806 degrees. So it's not just 152 degrees. I'm able to zoom in and see it's actually more precisely as I'm looking at the minutes and the seconds. Okay, so every angle has degrees, and also degrees have their own components inside of them, which is minutes and seconds. It's referred to in math as DMS. DMS. Okay, here's another example. Convert 30 degrees and 15 minutes and 50 seconds to decimal. Okay, so 30 degrees, 15 minutes, 50 seconds into decimals. Again, the first thing I do is take the minute, take the degree the way it is, and then I'm going to take the minute, divide by 60, take the seconds, divide that by 3600, and then add the result. You're going to get more precise measurement here. This is 30 degrees, 0.263, So that's more precise than just saying 30. How often would you use this? Not really often. We just wanted to be exposed to that measurement. Okay. We did this one. How many radians are in 35? Does anybody recall? How many radians are in 135? How many pi radians? Basically, we're asking how do you convert from 135 to pi radians. Does anybody remember that? 3 pi over 4. How many degrees are in, let's say, 4 pi over 3? How many degrees are 4 pi over 3? What is 4 pi over 3? Does anybody remember? You cut your pi into 3 parts. 180 divided by 3. Yeah. Another way to think of this one, which we're going to take a look obviously in the unit circle, this is 4/3 of the pi. Basically what you're saying here is also 1/3 of the pi, right? Times 4. So what's 1/3 of the pi? What's 180 divided by 3, which is 60? 60 times 4 is 240. More on this to come, obviously. Okay, that's just... Okay, now find the length. We're going to take a look at that right now. The arc length, we're going to have a formula for. And it's this one here. Arc length formula. This one says arc length formula is S equals R, the radius, times theta, which is the angle. And S is the arc length, R is the radius, theta is the radian. Radian, by the way, measures. Okay, so let's take a look at this example here. I have a circle with a radius of 4 inches and an angle of 60 degrees. And we're asked what is the arc length. Remember, this blue thing is the arc length. So I have to, this one here. We're gonna this blue, I guess, is the arc length that we're looking for. Let's do it here. I'm gonna use the formula here. So S equals the arc length equals R times theta, and remember this this theta is in pi radians. Okay, so if they're giving me here the radians in the theta in degrees, I have to convert that to pi radians. Just do it here. So what is 60 degrees in pi radians? What do you guys think? Convert from degrees to pi radians. That's a little bit too small, because 1/4, that means I took the 180, divided that into 4 pieces. So this, here we go. Yep. That is 1/3. You're right, Joe. 1/3, or pi over 3. 1/3 pi or pi over 3. So basically, I have 1/3 pi is what we're talking about here, times my theta. I'm sorry, times the r, which is the 3 here. So I will have pi over 3 times the 4. Which is 4 pi over 3. And if this, obviously they wanted this in radians, so I could just leave it the way it is, 4 pi over 3 inches. If you wanted to find out what's the pi, obviously you multiply by pi, right? So multiply 4 times the pi over 3, which is going to give you the decimal answer in inches. Yes, George, you will find out. We're going to have an awesome time with the unit circle. Yeah. And that's why I'm actually trying to get you guys started before the vacation. So, okay. Arc length obviously is used in like in the perimeter of the pizza, if you're interested in that. In navigation, the course or bearing of an object sometimes given as the angle of the line of travel measured clockwise from due north. There's a couple things about measuring here. Angular and linear motion. Angular speed is measured in units like revolution per second. If you're into cars, you know exactly what we're talking about here. Revolution per second. Per minute. RPMs. Is anybody here into cars? Is anybody here into cars? You probably would brag about the, hey, look at my RPM. Oh, I got this one. It's RPM. Okay, well, that's what we're talking about. Revolution per minute. How many times do you revolve per minute? The RPM. And the second one is linear speed, which is measured in miles per hour. You know this because you're probably driving or have ridden a car with somebody's driving. Okay, Jordan, here we go. Now talk to him about the RPMs. Okay, there's also another measurement, which is again the arc length, but this one is specifically for the Earth. Okay, it's called nautical miles. It's a nautical miles. A nautical mile is the length of 1 minute of arc length of arc along Earth's equator. So a mile, when you fly, for example, they use nautical miles, which is the 1 minute. 1 minute of flying or going around along the Earth equator of 1 minute long. That's the arc that we're talking about, this arc here. If you're flying or if you're into astrophysics or anything with the aerospace, you probably would love this. Nautical, or if you fly a lot of your travel. Nautical miles, okay? Nautical miles. Basically, they're telling you that you need to use the arc length in different applications, and this is one of them. 1 statute miles equals 0.8 nautical miles, and 1 nautical miles equals 1.5 statute miles. Okay, and I'm gonna pause here. Okay. This should conclude our lecture today on basic angles measurement, or angles and their measures. Be blessed wherever you're at.